Hello, everybody. Welcome back. Today we're going to be looking at Unit 5.10, which is called Multi-Step Reaction Energy Profiles. This subunit is going to sort of bridge the gap between reaction mechanisms. If you remember, those are the situations where you're given multiple elementary steps. So it's going to bring reaction mechanisms together with those graphs, those energy profile graphs that we were looking at. So let's get started. All right, so let's just review for one quick second before we get started here. We have looked at reaction mechanisms, and if you'll recall, a reaction mechanism has two or more elementary steps, and one of those steps is going to be the slowest in speed, and we called that step the rate determining step. Okay, I want you to also think about a concept we've talked about that relates activation energy and rate together. The higher a reaction's activation energy is, the greater that number is, the slower the reaction is going to proceed, because there's just going to be fewer reactant-reactant collisions with that required amount of energy. If you put those two concepts together, if you're looking at a reaction mechanism, it should make sense to you that the slowest or the rate determining step is the slowest step because it has the greatest activation energy. Okay, so I'm sort of bringing multiple concepts together. And we're going to look at this graphically and just prepare yourself for some pretty intense graphics here. I mean, if this whole teaching thing does not work out for me, I think that I have a career in graphic design. I mean, that graph is really something. Okay, so this is a poorly drawn energy profile. Okay, and we've seen energy profiles before, but we were looking at them with just one hump. Okay, we were looking at reactions that occur in just one step. But as we said, many reactions occur in multiple elementary steps. Okay, so this is the same, situation that we have had in the past. Let me just help you get your bearings one more time. The original reactants, that their potential energy is there on the left. The final products are there on the right. And the question here says, how many elementary steps are in this mechanism? It's not a trick question. The answer is what you think it probably is. There are 3 elementary steps in this mechanism because there's 3 bumps on the graph. Okay. Which step of those 3 is rate determining? Remember, guys, what we said just a moment ago. The rate determining step is the slow step because it has the highest activation energy. And remember, guys, activation energy for each of these bumps is the distance from the reactants to the top of the hill, or to the level of the activated complex. So in this second elementary step, that's the activation energy there. And then for the third one, it's there. Okay, so which step is going to be rate determining? Hopefully you can tell. It is the second middle elementary step. And if you had to defend your answer, you would say because it has the greatest activation energy. Please don't say because it's the biggest bump. Okay, that's not going to get you credit. Okay. Now, we talked about this a little bit before as well. Endo versus exothermic reaction profiles. Okay, remember that if a reaction profile is in general uphill, when I say uphill, I mean like the products are at a potential energy higher than the reactants. That's the general shape for an endothermic curve. If the products are at a lower energy point than the reactants, then that's an exothermic curve. So if I'm looking at each one of these individually, okay, sort of marking out the levels, okay, so this first curve, this first elementary step is endo, because from reactants to products was an uphill climb. Don't say that on a test. You would say the products of step 1 are at a higher energy level than the reactants of step 1. Okay. Elementary step 2 is also endo. Again, because the products of step number 2 are at a higher energy level than the reactants of step 2. However, the third elementary step is exo, because the products are lower than the reactants on the y-axis. Okay. Final question, where are the intermediates? Where are the activated complexes, or that can also be called the transition states? Okay, guys, let's refresh our memories on the term intermediate. Okay, we saw that term when we first introduced reaction mechanisms. An intermediate is something that is a product of one elementary step, which is then consumed as a reactant in a later step or the following step. Okay, if you think about that, you should realize that the intermediates are going to be found in the valleys of this reaction profile. Okay, because if you follow step number 1 here, right there is where the products of step 1 are located. It's also the place where the reactants of elementary step 2 would be found. And that's what an intermediate is. It's a product of one step and then is consumed as a reactant in a later step. So our intermediates are found in the valleys. And the second question is really review. The activated complexes or transition states, remember that's the term that means like kind of the hybrid between reactants and products. And those are found at the peaks, okay, where we are transitioning between reactants and products in each step. Okay, so there's lots of things to identify on these reaction profiles. So what I want you to do is to pause your video and try this problem. You are asked to sketch a reaction profile for the mechanism below. Okay, for each elementary step, you're told whether it's endo or exothermic. Okay, so that'll give you in general what shape each step should have. You're also given speed information. And we can see that step 1 is the slowest step. So I want you just on a scratch piece of paper, try sketching out what the shape of this curve might look like. Let's see how you did. In general, this is kind of what your sketch should look like, okay? So this would likely be like a 3-point question, okay? This is free response. 1 point would be earned for simply having 3 bumps on the graph, because that shows the graders that you understand that each elementary step is going to have its own curve. So 1 point would likely be earned for simply having 3 bumps. A second point would be earned for showing that each individual bump, each individual curve has its products lower than its reactants because each curve was exothermic. A third point would likely be earned for simply having the first curve for the step 1 being the tallest. Why? Because we were shown that it was the rate determining step, so it must have the greatest, highest activation energy. Okay, and I will tell you guys that as the years go on more and more, the AP exam is having students draw things on free response more and more, rather than just answering rote memorization kinds of questions. They are having you sketch things out. So that's something that you could definitely see on the AP exam. So I hope you have learned a little something today, and I look forward to seeing you next time.